Okay, ma? So the next topic which we are studying is electrolytes, ma? So what is meant by electrolyte? Which gives ions when they are placed in water is called as electrolytes. Clear, ma? For example, if I take NaOH and put it in water, then it ionizes into Na plus and OH minus. So this is an electrolyte. Are you able to understand? Similarly, CH3COOH, when it is put in water, it converts into CH3COO minus plus H plus. This is also an electrolyte. Are you able to understand? So they should split into ions when they are placed in water. So then they are called as electrolytes. For example, glucose, C6H12O6. So here there will not be any ionization, no ionization. So therefore glucose I cannot call it as an electrolyte. Are you able to understand? Because it doesn't split into ions when it is mixed in water. Clear? So C2H5OH, alcohol, this also doesn't ionize. Are you able to understand, ma? Similarly, ROR, ether also doesn't ionize. So these are not called as electrolytes, ma? Only those which gives ions in water, they are called as electrolytes. And when you study about a type of electrolytes, you can divide them into two types. So first one you can call them as strong electrolytes. 1 minute. Khandan anta utartada anamata. Okay, ma. So electrolytes we can divide them into two types, ma. So one is strong electrolytes, and next one you can call them as weak electrolytes. Okay. So strong electrolytes means what, ma? How can you say what is meant by strong electrolyte? Strong electrolyte means alpha value, it is almost equal to 1. Okay. So what is meant by alpha value? Already we have studied in chemical equilibrium, no? Alpha value means what?
X by A.
X by A, very good. So alpha is nothing but X by A. Okay, ma? So X is the extent of dissociation and A is called as number of moles of products. Are you able to understand? So it means almost all the molecules, if they are ionizing, then you will get alpha value is 1 number. So alpha value X indicates that X and A both are equal. It means if 4 moles of products are there, all the 4 moles should dissociate into ions. Are you able to understand? Then I can say alpha value is almost equal to 1. So examples of strong electrolytes are what? Strong acids. Okay, ma? So already we have done one problem on a CH3COOH, no, ma? That was based on this question, actually, this concept. Okay. Similarly, strong bases and salts. So these are examples of strong electrolytes. So they 100% almost, they ionize into ions. Clear? Weak electrolytes means what? Alpha value, it's much less than 1. Very, very less. It means only very few molecules they will ionize, remaining molecules they will not ionize when they are placed in water. So alpha value is much less than 1. Are you able to understand? So, and what is the example of this one? Weak acids, okay, ma? And weak bases. So these are the examples of weak electrolytes. Okay, make a note. Okay, ma? So next we are studying pH of a solution. So this is a solution, ma? It can be acidic, it can be basic, it can be neutral also. So what is pH? It indicates what, ma? It indicates acidity or basicity of a solution. Okay. So if solution is acidic or basic, that we can understand by looking at the value of this pH. So if pH value is 7, then solution is called what kind of solution? Solution is called as neutral solution. Are you able to understand, ma? Aqueous solution. Similarly, if pH is less than 7, then solution is called acidic solution. Okay. Similarly, if pH value is greater than 7, then solution is called as more basic in nature, or you can call it as a basic solution. Okay. Similarly, what is meant by pH? pH is the negative logarithm of H plus ion concentration. Are you able to understand, ma? Of solution. So this is called as pH. Similarly, what is meant by POH, ma? POH is called what? It is the negative logarithm of OH minus ion concentration of solution. Clear? So it means if you write them mathematically, how can you write them mathematically? I can write pH is equals to negative log of H plus of solution. Clear, Nama? This is, we are writing H plus of solution. We are not writing H plus of acid. So be careful about that. Clear, no? Similarly, POH, how I can write? I can write, it is also the negative logarithm of OH minus concentration of solution. Are you able to understand? Similarly, H plus ion concentration of solution, how I can write? I can write it as 10 power minus 7 plus H plus ion concentration of acid. This is how I have to write now. Are you able to understand now? Similarly, OH minus ion of solution, how I can write? So this is also equal to 10 power minus 7 plus OH minus concentration of base. This is how I have to write. Clear number? Then in this one we have some cases. What are the cases we have? Okay. So case is that if H plus concentration of acid or OH minus concentration of base, okay ma, if they are much greater than 10 power minus 7. Okay. So H plus ion concentration of acid or OH minus concentration of base, if they are much greater than 10 power minus 7. Much greater than 10 power minus 7 means what? 100 times greater, 1000 times greater, 10,000 times greater. Okay. Then what we can do? Then we can neglect. Okay, ma? Then we can neglect 10 power minus 7 in equation 1 and equation 2. Okay. Which is the first equation, which is the second equation. This one I can call it as first equation and this one I can call it as second equation. We can write like this now very simply. So H plus ion of acid or OH minus ion of base, if they are much greater than 10 power minus 7, then here 10 power minus 7 will become very small value, no? That one you can neglect. So directly you can write H plus ion of solution is nothing but H plus ion of acid. Similarly, OH minus ion of solution is equals to OH minus ion of base. We can write like this. Are you able to understand? Make a note. Already raskuna. Okay, ma? So let us see case number 1 in calculation of this pH and POH values. Ma? So first case is calculation of pH value of strong acid. Okay. See, ma, for example, consider this is any acid. A general form we are writing. We are not taking any acid. General form we are taking. Okay, ma? So HNA, it dissociates into NH plus plus A to the power of N minus. Can I write like this? Okay, ma? For example, if you take HCl, okay, how many hydrogen atoms are present in this molecule? Only one. It means here N value is nothing but 1, no? Are you able to understand? So HNA, it means in an acid molecule, one hydrogen may be present, 2 may be present, 3 may be present. Any number of hydrogens can be present depending on the acid. Are you able to understand, ma? So HNA finally converts into what? N number of H plus ions and then automatically A to the power of N minus. This is what we will get now. For example, HCl dissociates into what? It dissociates into H plus plus Cl minus. Okay. So how many hydrogens are there? One hydrogen. So therefore it dissociates finally into only one hydrogen. So only one negative symbol you will get for chlorine. Are you able to understand, ma? Similarly, if you take H2SO4, how many hydrogens are present? 2 hydrogens are present. So what is the final equation I can write? Okay, my final equation which I can write is H2 plus plus SO4 or I can write 2 into H plus plus SO4 2 minus. I can write like this number. They finally dissociate into 2 hydrogen and SO4 to the power of 2 minus because it is losing 2 hydrogens number. So 2 negative symbols it will get. Are you able to understand how we are writing the general form? Are you able to understand? So HNA finally converts into NH plus and A to the power of N minus. A can be anything. Here it is Cl, here it is SO4, like this. So this is the general equation we are writing. Are you able to understand? So therefore, now if I write the previous equation, what was the previous equation we have written? H plus ion concentration of solution. This is equals to 10 power minus 7 plus H plus ion concentration of acid. This is what I have written. This was the equation we have written, no? Do you remember? Everywhere we are writing the same equation. This equation you are supposed to by heart. Are you able to understand? Okay. Now if I see this H plus of acid. So this is the H plus ion of acid only, no? So in this particular equation, how many H plus are present? N hydrogens are present, you know. So this equation I can write it as N into concentration of acid. This is how I can write. Are you able to understand, ma? Or just you can write N into the concentration of HNA. HNA is the acid which I have taken, no? Are you able to understand? So this is another equation. Now this is my first equation and this is my second equation. So what I can do, I can substitute 2 in equation number 1. Are you able to understand? So H plus ion of acid, how I can write? So how many number of H plus are present in the equation? N. So N multiplied by the concentration of acid. What is the acid here? HNA is the acid. So this is the method of writing. Are you able to understand? So if I substitute a second equation in first equation, then how I can write? I can write H plus ion concentration of a solution. This is equals to 10 power minus 7 plus H plus ion of acid. And H plus ion of acid, how I can write? I can write N into concentration of acid. Are you able to understand? N into concentration of acid also, how I can write? N into HNA. Okay, ma? So this is the method of calculating pH values for strong acid. Are you able to understand? So make a note up to here. We will do some examples, no? Then you will understand what is the method of calculating the pH value of strong acids. Okay? Okay, ma? So first question is calculate the pH of 10 power minus 3 molar HCl. Are you able to understand? So what was the equation we have written, ma? So H plus ion concentration of solution is equals to 10 power minus 7 plus, so H plus ion concentration of acid. This is how we have written, no? So H plus ion concentration of acid, again how I can write? I can write N multiplied by concentration of acid. This is how I can write, no? Do you remember all these steps? Clear? So therefore, can you say here N value is how much? N value, huh? N value 1 only, no? In this formula, only one hydrogen atom is present. So HCl can be written as H1Cl1, no? Are you able to understand, ma? So therefore N value is 1. And what is the concentration of acid given? 10 power minus 3. This is the value which is given, no, ma? So take this value and substitute in the original equation. So H plus ion concentration of a solution, this is equals to 10 power minus 7 plus 10 power minus 3. Okay. Now what is the case which we have to substitute here, ma? Yes, because concentration of acid, it is much greater than 10 power minus 7, no? How many times greater? 10 power 4 times. 10,000 times it is greater. So therefore you can neglect 10 power minus 7. This is because a very big value when compared to 10 power minus 7. Okay. So therefore as 10 power minus 3 is much greater than 10 power minus 7, what we do? We neglect the value of 10 power minus 7. So therefore what is the final answer we have to write, ma? Final answer is H plus ion concentration of a solution is equals to 10 power minus 3. Okay. So solution concentration I got, no? 10 power minus 3. Now how can I calculate a pH value? pH value how can I calculate, ma? It is negative logarithm of H plus concentration of solution, no? Do you remember? Okay. So it means to this concentration of solution, just you are supposed to add the negative log. So substitute negative log here. So minus logarithm of 10 power minus 3. Okay, ma? So we know this real normal log x power n can be written as n into log x. Can I write like this? So according to same relation, do this calculation. So pH is equals to minus of minus 3 log 10 to the base 10. So we are not taking a natural logarithm, no? We are taking log to the power base of 10 itself. So log 10 to the base 10 is 1. So therefore what is the final answer I got? So plus 3 multiplied by 1 is equal to plus 3. Okay, ma? So this is the pH of this solution. Okay. So pH is 10 plus 3 means is it behaving like an acid or is it behaving like a base? Chapandi. No, it is behaving like an acid. Why? Because its value is less than 7, nama. Strong acid or weak acid? Strong acid, because 3 is much smaller when compared to 7. Okay. Similarly, if I want to calculate its POH value, how can I calculate? POH value if I want to calculate, how can I calculate, ma? 14. So pH plus POH is equals to 14. Already we have written this value, no? Clear, no? So pH value is how much? 3. POH I don't know, but both of them they should be equal to 14. So therefore POH is equals to 14 minus 3, which is equals to 11. Are you able to understand? So this is the POH value of this solution. Okay. So this is much greater than 7 number. So it means it is a very weak base. It is a very weak base and a strong acid. That is the meaning of this. Are you able to understand? That's it. Okay. So let us see the next question. Calculate the pH of 10 power 8 molar HCl. Okay. So now let us do the calculation. This is again same, no? H plus of solution is equals to 10 power minus 7 plus H plus of acid. Okay. So H plus of acid is how much? N into the concentration of acid. Okay. So 1 into what is the concentration of acid? Concentration of acid is 10 power minus 8. So take this value and substitute in the original equation. So therefore H plus of solution is how much? 10 power minus 7 plus 1 into 10 power minus 8. Okay, ma? So this is 10 power minus 7 plus 10 power minus 8. Now 10 power minus 8, is it smaller than 10 power minus 7 or bigger than 10 power minus 7? Ma? Smaller than 10 power minus 7. So shall we neglect 10 power minus 7 here? We cannot neglect 10 power minus 7 because 10 power minus 7 is a much bigger value. 10 times more bigger value when compared to 10 power minus 8. Okay. So here 10 power minus 7 cannot be neglected. Okay. So therefore if I don't neglect this one, I will try to convert this total value in terms of either 10 power minus 7 or 10 power minus 8. Okay. So if I want to convert this one in terms of 10 power minus 7 only, then one thing which I can do is I can write it as 1 by 10th of 10 power minus 7 number. 10 power minus 8 can be written like this. Are you able to understand? 10 power minus 8, are you able to understand? It is 10 times smaller when compared to 10 power minus 7. So therefore I am writing 1 by 10th of 10 power minus 7. Okay. So therefore H plus concentration of solution, this is equals to 10 power minus 7 plus 1 by 10 can be written as 0.1 norma, 0.1 multiplied by 10 power minus 7. 10 power minus 7 if you take common, then what I am left with? I am left with 1 plus 0.1. 1 plus 0.1 is how much? 1.1 into 10 power minus 7. That's all, no? So this is the H plus concentration of solution. Okay. Now how to convert this one value in terms of pH? That we will see. Okay. So we will write a formula here. So H plus concentration of solution, this is of which form? This is of the form of X into 10 power minus Y. This is of this form, no? X value is 1.1. Okay. So 1.1 multiplied by 10 power minus Y. This is of this form. Then the pH can be written as, okay, so Y minus log X. This is one general relation which you can always remember. Are you able to understand, ma? So there, current okay. So see, so pH of the solution, this is the equation number Y minus log X. If H plus of the solution is of this format, X into 10 power minus Y, then pH can be written like this. So what is the pH of the solution? I got 1.1 into 10 power minus 7. So substitute that value. So therefore pH is equals to, so what is Y value here? Y value is 7 norma, minus Y is minus 7. Minus Y value is minus 7. But here we have written only Y value, no? So I will write 7. So 7 minus log X. What is X value here? X value is nothing but 1.1. So 7 minus log 1.1. So this is the pH of this particular solution. Are you able to understand? Make it. Okay. So this is one more example. Calculate the pH of 10 power minus 3 molar H2SO4. Clear? So what is the equation which we have written, ma? So H plus of solution is equals to 10 power minus 7 plus H plus ion concentration of acid. This is what we have written, no? So what is the H plus ion concentration of acid? It is nothing but the number of atoms of hydrogen multiplied by the concentration of acid. That's what we have written previously, no? So directly we will write here. So H plus of solution is equals to 10 power minus 7 plus how many atoms of hydrogen is present? 2. So 2 multiplied by, and what is the concentration? 10 power minus 3. That's all, no? This is how we write. Clear? Now here 10 power minus 3 is very big when compared to 10 power minus 7. So therefore this value can be neglected. 10 power minus 7 I can neglect, no? So therefore, what is H plus of solution? So this is equals to, so 2 into 10 power minus 3. This is the value which I got. Okay. Now this is of which form? This is of the form of H plus is equals to x into 10 power minus 5. That is the format in which this one is presented. So therefore, how can I calculate the pH of this particular solution? So y minus log x, that is the method which we have adopted. No, here y value is nothing but 3 minus log x value is nothing but 2 here. So pH is equals to 3 minus log 2. That's all. That is our answer. Are you able to understand? That's it. Make a note. Okay, ma? So second case which we are studying is pH of strong base. I want to calculate. Okay. Now until now we have calculated pH of strong acid. No? Now I am calculating pH of strong base. So what is the note point we have written? First we are supposed to calculate a POH of the base. Then automatically you will get pH of the base also, because pH plus POH is equal to 14. That number already we know. Okay. So therefore let us take one strong base. That, let us write in general form. For example, I will write BOHN. It means how many OH molecules are present in this base? N OH molecules are present. Are you able to understand? So if they disintegrate continuously, then what is the final answer I will get? So it can be separated into N OH minus, they can disintegrate into N OH minus. Okay. Then B N power minus. I can write like this. Can I write like this? Are you able to understand? So for example, if I take NaOH, it can get separated into OH minus plus Na plus. This is how I have to write. No? So here how many OH molecules are present? Only one OH is present. So if OH ion gets separated, then sodium will get only one positive symbol. Are you able to understand? But here how many OH are present? N OH are present. So therefore B will get to the power of N minus. Are you able to understand? So this is the general equation in which I have written the dissociation of a base. Okay. Now in the same manner how we have written a H plus of a solution, I can write OH minus concentration of solution. OH minus ion concentration of solution. How can I write? I can write it as again same format. 10 power minus 7 plus OH minus ion concentration of base. This is the method. Same format. In acid and base, we are using the same format of equations. Okay. So OH minus ion of solution is nothing but 10 power minus 7 plus OH minus ion concentration of base. Okay. Then how can I write OH minus ion concentration of base? OH minus ion concentration of base can be written as, okay, so how many OH molecules are present here? N OH molecules are present. So N multiplied by, so OH, or you can write concentration of base. What is the base here? B OH N. This is how I have to write. Or just you can write N multiplied by the concentration of base which we have taken. I can write like this. Are you able to understand? So therefore total equation how I can write OH minus ion concentration of solution is nothing but 10 power minus 7 plus N into concentration of base. That is how I have to write. Are you able to understand? Make a note, then I will give you some examples. Try to do the examples. So first example is calculate the pH value of NaOH, 10 power minus 3 molar NaOH. Okay, ma? Come on, try to do this calculation. 10 power minus 3 molar NaOH solution. Anybody? Okay. So OH minus ion concentration of solution is nothing but 10 power minus 7 plus OH minus ion concentration of the base. Okay. So OH minus ion concentration of base can be written as, okay. So how many OH are present here? Only one OH is present. So 1 multiplied by the concentration of the base, which is nothing but NaOH. And what is the concentration of the base given? 10 power minus 3. So I will write 1 into 10 power minus 3. That is how I have to write now. Now substitute in the original equation. Okay, ma? So therefore I will write OH minus ion concentration of solution is equal to 10 power minus 7 plus 1 into 10 power minus 3. This is how I can write. Okay. So 10 power minus 3 is very big, no, when compared to 10 power minus 7. So you can neglect 10 power minus 7. So OH minus ion concentration of solution is nothing but how much? No, it is 10 power minus 3. Okay. And how can I calculate a POH? POH is nothing but the negative logarithm of OH minus concentration of solution. This is how we calculate pH and POH number. Negative logarithm of H plus or OH minus ion concentration is nothing but pH. Okay. So substitute here. So therefore POH is how much? Negative logarithm of, clear ma? So how much this value? It is 10 power minus 3. Clear number? So therefore we know this equation of logarithm number. Log x power n, how can I write? N into log x. This is how I can write, no? So according to this relation, if I calculate the POH value, then how much it is? So minus of minus 3 log 10 to the base of 10. Log 10 to the base of 10 is 1. So therefore POH of solution is how much? It is plus 3. Understood, no? So POH is 3. Then how much will be pH? 11. How I got 11 value? Because pH plus POH total should be equal to 14. That's all, no? So therefore pH is nothing but 14 minus POH. So this is nothing but 14 minus 3, that is equals to 11. So pH value 11 indicates it is a weak acid and a strong base. That is the meaning of this one. Clear, no? Right. Okay, ma. So these are the two questions of calculating pH of the base, ma. Okay. So now let us see how we can proceed. So OH minus concentration of solution is equals to 10 power minus 7 plus, how many OH are there, ma? 1 OH is present. So therefore 1 into what is the concentration? 10 power minus 8. See, ma, 10 power minus 8 is not very small when compared to 10 power minus 7. So here in this condition 10 power minus 7 cannot be neglected. You cannot neglect that one. So therefore I will write 10 power minus 7 plus 10 power minus 8 is how many times smaller? 1 by 10 times smaller when compared to 10 power minus 7. Okay. So therefore I will write 10 power minus 7 if I take common, then it is 1 plus 0.1. Clear number? So 1.1 into 10 power minus 7. So this is again of the format of x into 10 power minus y, no? So therefore POH, how can I calculate? POH is equals to 7 minus log 1.1. Okay. But I want to calculate the pH, no? So pH value is how much? 14 minus 7 minus log 1.1. Okay. So 7 plus log 1.1. So that is the POH of the solution. Understood, no? Similarly, do this calculation pH of 10 power minus 3 molar AlOH taken thrice. Clear? So again same concept. So OH minus ion concentration of solution is nothing but 10 power minus 7 plus, how many OH are present? 3. So 3 times of 10 power minus 3. That's all, no? So but here 10 power minus 3 is very, very bigger when compared to 10 power minus 7. So you can neglect that one. So therefore OH minus ion concentration of solution is how much? 3 into 10 power minus 3. That's all. So again this is of the format of x into y power, x into 10 power minus 3 minus y. So therefore what is the POH? It is nothing but 3 minus log 3. That's all. No? So therefore pH is how much? pH is nothing but 14 minus of 3 minus log 3. So 11 plus log 3. Okay. So that is the pH of this base. Okay. That's it. So this is how we can. Okay, ma? So next we are discussing about case number 3, ma. Case number 3 is we are taking a mixture of two strong acids, ma. Clear? So HNA is one acid, HMA is another acid. So in this acid, how many hydrogen atoms are present? N number of hydrogen atoms are present, and in this one, M number of hydrogen atoms are present. So both of them, they are mixed in a container, and I want to calculate their pH of the total mixture. Okay, ma? So in this condition I can write, So H plus ion concentration of a solution, this is equals to, so H plus ion concentration of acid number 1 plus H plus ion concentration of acid number 2. So this is the formula which we use to find out the concentration of two strong acids. Are you able to understand, ma? So H plus ion concentration of first acid plus H plus ion concentration of second acid. Previously, in the previous cases, what was the method we have used, ma? H plus ion concentration of solution is equals to 10 power minus 7 plus H plus ion concentration of acid or base. This is what we have written. No? Now here just we are adding the H plus ion concentration of first acid and second acid. Clear? So how can I calculate H plus ion concentration of acid, ma? Yesterday we have discussed, no? Okay. So this is nothing but, if you take acid number 1, this is my acid number 1, no? So how many hydrogen atoms are present? N. So N multiplied by concentration of HNA. This is how I can write H plus ion concentration of acid, no? Okay. Similarly, what is the H plus ion concentration of second acid? How many atoms of hydrogen are present? M. M multiplied by HM into A. That is the concentration of second acid. Are you able to understand, ma? So this is how I can write. Now this H plus ion concentration of solution, how can I calculate if two acids, if they are mixed? In the basic concepts of chemistry you should have studied, no, ma? If two acids, if they are mixed, how can you calculate the combined concentration of both of them? So this is the formula which we can use. Which formula? So N multiplied by M1 V1 plus M multiplied by M2 V2 divided by V1 plus V2. This is the formula which we can use. Are you able to understand, ma? So what is N here? N is the number of atoms of hydrogen which are present in first acid, and M is the number of hydrogen atoms which are present in the second acid. What is M1? M1 is the molarity of first acid, M2 is the molarity of second acid. V1, volume of first acid, V2 is the volume of second acid, divided by V1 plus V2. This is the formula which we use. Are you able to understand? So make a note up to here. Okay. So this is the question. So calculate the pH of these two strong acids, no? Which are the two strong acids here? Both of them, they are taken HCl only, but one is 100 ml and 10 power minus 2 is the concentration. Second one is 200 ml and 10 power minus 3 molar. Are you able to understand? So therefore, how can I calculate H plus ion concentration of the total solution, ma? So this is equals to N. Let us take this one to be first acid and this one to be the second acid. So N value is how much in this acid? 1, because only one hydrogen is present in HCl. So 1 multiplied by, what is the molarity, ma? 10 power minus 2 multiplied by volume 100 ml. But 100 ml I have to convert into liters, no? So 10 power minus 3 you have to write. But no need of writing 10 power minus 3, no, ma, because volume is present in denominator also. So 10 power minus 3 will get cancelled with each other. So no need of substituting. Okay. So plus, what is the M value of second acid? Here also H value is 1 only, no? So 1 multiplied by, molarity is how much? 10 power minus 3 multiplied by volume is 200 divided by 100 plus 200. That's all, no? So let us do this calculation, ma. So 0, 0, 0, 0, 0, 0, 0 and 0 will get cancelled. So 10 power minus 2 plus 2 into 10 power minus 3 divided by 3. 1 plus 2 is 3. Clear, no? So therefore this calculation, how I can write? I can write it as 10 power minus 2 can be written as 10 into 10 power minus 3 plus 2 into 10 power minus 3 divided by 3. Clear, no? So 10 plus 2 is 12. 12 by 3 multiplied by 10 power minus 3. So I can write like this. Okay. So therefore if you do this calculation, how much it will be? So 4 into 10 power minus 3. So this is the H plus ion concentration of this solution. Are you able to understand, ma? Then how can I calculate a pH of the solution? He is asking us to calculate a pH, no? pH, how can I calculate? Already we studied, no? It is the negative logarithm of H plus ion concentration of the solution. Already we have studied many times, no? So therefore a negative logarithm of 4 into 10 power minus 3. So this is of which form? This is of the form of x into 10 power minus y. So therefore pH, how can I write? So 3 minus log 4. Rule we have studied in the last class, no? So this is the method of calculating pH of this mixture of solutions. Is it clear? Right. Okay, ma? So next we are studying case number 4. What is case number 4, ma? pH of mixture of two strong bases. Okay, so here also we will proceed in the same manner, ma, how we have proceeded in the cases of mixture of strong acids. Okay, so how can I write? So these are the two strong bases which I am taking, ma. Okay, so BOHN, BOHM. It means how many OH ions are present here? N OH ions here, M OH ions are present. So OH minus ion concentration of solution is equals to OH ion concentration of first base plus OH ion concentration of second base. Are you able to understand? So therefore, OH minus ion concentration of solution can also be written as, if you take this one to be first base, how many OH minus ions are present here? N. So N multiplied by concentration of base number 1, which is the base number 1, BOH N. Okay. And how many OH minus ions are present in second base? M. M multiplied by concentration of second base. Are you able to understand, ma? So this is the method. Then how can I calculate the OH minus ion concentration of a total solution? Again, same formula. Are you able to understand? So here instead of H plus, what I can write? I can write OH minus ion concentration of the solution is equals to, again, same formula. N into M1 V1 plus M into M2 V2 divided by V1 plus V2. That's it. Are you able to understand? So I will give one example. Try to calculate the answer of this one. Okay, ma? So do this calculation. So 500 ml 10 power minus 3 molar NaOH is mixed with 400 ml 10 power minus 3 molar BaOH taken twice. Okay, ma? So calculate the pH of this particular mixture. Come on. Okay. Anybody got the answer? 13 by 9 into 10 power minus 3. pH value? pH కావాల్సింది. Okay. See, ma. So therefore, how to calculate OH minus ion concentration of solution? Same formula, no, ma? This formula. So for example, you take this one to be our first base and this one to be our second base. So how many OH minus ions are present in NaOH, ma? Only one is present. So N value is how much? 1 multiplied by 10 power minus 3. And what is the volume of this one? 500. Plus, what about second one? 2 BaOH are present. 10 power minus 3 multiplied by volume is 400 divided by 400, 500 plus 400. This is the calculation, no? So therefore, OH minus ion concentration of the solution is equal to how much? So 0, 0, 0, 0, 0, 0, 0 and 0 will get cancelled. So therefore, it is equals to 10 power minus 3 plus 2 into 10 power minus 3 divided by 5. 5 is also there, no? So 5 into 10 power minus 3 plus 4 2s are 8, no, ma? So 8 into 10 power minus 3 divided by 5 plus 4 is 9. So total how much? 13 by 9 multiplied by 10 power minus 3. This is the answer which I got. 13 by 9 approximately 1.25 can be right? 4.5, 4 only, 1.4 we can write. Okay, ma? 1.4 multiplied by 10 power minus 3 approximately. Okay. So therefore, how to calculate the pH value of this one? pH value is 3 minus log 1.4. This is the pH value. Then how can I calculate a POH value? POH, how can I calculate, ma? So POH plus pH is equal to 14. Okay. So therefore, POH value is equals to 14 minus pH. So 14 minus pH value is log 1.4. So 11 plus log 1.4. That's all. That is my answer. Understood, no? So here, first of all, you calculate POH, ma, then you calculate pH value of the solution. Clear? That's it. Okay, ma? So case number 5 which we are taking is pH of mixture of a strong acid and strong base, ma. Clear? Previously we have studied mixture of two strong acids and two strong bases separately. Now what happens if I mix a strong acid and a strong base? Are you able to understand? And in this one, again we have to study three conditions, ma. Case number one is subcases. Okay, ma. Case number one is, what is the case I can write here? So H plus ion concentration of acid is equals to OH minus concentration ion of base. Okay. So concentration of acid and concentration of bases, they are same. In this condition, what will happen? Salt will form, no, ma. So solution will it will not be acidic, it will not be basic. So both of them, they react together and salt will be formed here. And what is the pH value of a salt? pH value of a salt is equals to 7. That's all, no, ma. This is our first case. Then we study case number 2. What is case number 2? H plus ion concentration of acid, it may be greater than OH minus ion concentration of a base. This is second case which is possible. Okay. Then solution is what kind of solution, ma? Solution will become acidic solution because the concentration of H plus ion is greater than concentration of OH minus ion. So solution is definitely okay. We know. Okay, ma? Solution is what kind of solution? Solution is acidic solution. Are you able to understand? So therefore, how can I calculate H plus ion concentration of total solution? I can write like this. So N multiplied by M1 V1 minus M multiplied by M2 V2 divided by V1 plus V2. This is the equation which I can write. So previously when we have taken two acids or two bases, here there was plus symbol. So here instead of plus symbol, just we are writing minus symbol. Are you able to understand? This is our second case. Then what is case number 3? Case number 3 is H plus ion concentration of acid may be less than OH ion minus concentration of base. Then solution is what kind of solution, ma? Solution is basic solution. Clear? So solution is basic. Okay. Now in this condition, how can I calculate OH minus concentration of solution? Again same concept. Previously here we have written N into M1 V1, no, ma? Now OH minus ion concentration is greater, no? So therefore I will write M into M2 V2 minus of N into M1 V1 divided by V1 plus V2. That's it. Are you able to understand? So write down. So therefore how can I calculate? So OH minus ion concentration of solution is nothing but, so M1 M2 V2 minus N M1 V1 divided by V1 plus V2. That's all. This is our calculation. Have you understood? So once you calculate OH plus or OH minus of the solutions, we know how to calculate pH values. No? That's it. Once you calculate pH, you can calculate POH of the solution also. Is it clear? Right on. Okay, ma? So see the first one. So calculate the pH of this mixture of acid and base. Similarly, this mixture of acid and base. Okay, ma? So first of all, we have to check the concentrations, no, ma? Check the concentrations. Okay. So how can I check the concentrations? Okay, very simple. So H plus ion concentration I can do like this. So N into M1 V1. Similarly, OH minus ion concentration I can calculate like this. So M multiplied by M2 V2. Clear, nama? So what is N value of HCl? 1. 1 multiplied by 10 power. This is not plus 2, ma. This is minus 2. Plus 2 తీసుకొని చేసినారా కొంపదీసి? వావ్, ఇంటెలిజెంట్. ఎప్పుడన్నా 10 పవర్ ప్లస్ 2 మోలార్ హెచ్సిఆర్ చూసారా చరిత్రలో? ఓహో, నేను ఇచ్చినా సరేలేండి, మీరు ఎప్పుడన్నా చూసినారా? చూడలేదు. ఓకే, రైట్. సో 10 power minus 2 multiplied by volume is how much, ma? 100. So you need not convert this one into liters, ma, because just we are comparing, no? You need not convert. Okay. Similarly, this one, M value, OH ion concentration, OH ions are how many, ma? Only 1. So 1 multiplied by 2 into 10 power minus 2 multiplied by volume is 50. Clear, no? So therefore, see, 100 into 10 power minus 2. This is also 100 into 10 power minus 2. Both are equal, no? Clear, no? So therefore, H plus ion concentration and OH minus ion concentrations, they are equal. So therefore, if they react with each other, salt will form. Okay, no? So then what is the pH of the salt? pH of the salt is 7. That is my answer. Understood, no? Now do the second one. Okay. So therefore, H plus ion concentration is how much? 1 multiplied by 10 power minus 2 multiplied by 100. 1 minute. Okay, ma? So therefore, OH minus ion concentration is how much, ma? So this is also 1 multiplied by 2 into 10 power minus 2 multiplied by 100. So which concentration is greater? Definitely OH minus ion concentration is greater than H plus ion concentration. So therefore solution behaves like a base. So solution is basic solution. Are you able to understand? So therefore, how can you calculate the OH minus ion concentration of the total solution? Okay, ma? So M multiplied by M2 V2 minus N multiplied by M1 V1 divided by V1 plus V2. Okay. Now substitute the values. This one completed, no, ma? Okay. So what is M value, ma? OH minus concentration of solution. OH minus M value is 1 only. 2 into 10 power minus 2 multiplied by 100 minus 1 into 10 power minus 2 multiplied by 100 divided by 100 plus 100. Clear, no? 100 plus 100 only, no? So therefore, zeros I will cancel. So it is 2 into 10 power minus 2 minus 1 into 10 power minus 2 divided by 2. Okay, ma'am? So therefore, how much it is? 1 by 2 into 10 power minus 2. So 0.5 into 10 power minus 2. So this is the OH minus concentration ion of solution. Clear, no? So once you calculate OH minus ion concentration of solution, can't you calculate its POH value, ma'am? POH is how much? POH is equals to 2 minus log 0.5. That's all, no? So therefore pH value 14 minus of 2 minus log 0.5. Clear, no? So 12 plus log 0.5. That is my answer. Understood, no? So this is how you can calculate the pH of solution if a strong acid and a strong base when they are mixed with each other. Is it clear, ma? Case number 5. Okay, ma? So next case number 6 is how to calculate a pH if some water is mixed to acid or a base, ma? Are you able to understand? Previously they were aqueous solutions. Now I am adding additional some water. Whether it is an acid or whether it is a base, then how can I calculate the pH after it is diluted? Diluted means what? We are adding some water to that one. Clear, no, ma? So this is the condition. So this is the acid. Okay, and this is water which is added. Then HNA remains to be HNA only. Are you able to understand? So we are not adding another acid or we are not adding another base, no, ma? So nothing will change. That's just the solution will become diluted solution. That's it. Are you able to understand? So N value is how many hydrogens are present. M value is the concentration and V is the volume of the acid. Divided by what? Divided by total volume. That is the initial volume of aqueous solution of acid plus the additional volume of water which you have added. Are you able to understand? So if you take this ratio, I will get the H plus ion concentration of solution. Same concept with respect to base also. If it is a base, how can I write? M multiplied by M into V1 divided by V1 plus V2. That's all. Whether it is an acid or whether it is a base. Just we are adding water, no, so volume increases. Okay. So volume is increasing, so therefore I am writing V1 plus V2. Okay. Now do this problem. What is the problem given here? 1 liter 10 power minus 3 molar H2SO4 solution is diluted 4 times. Okay. Then find its pH. Okay. Diluted means water is added. 4 times means what? If the volume of original solution is 1 liter, additionally 4 liters of water is added. That is the meaning of this one. No? So therefore do the calculation. Okay. So H plus ion concentration of solution is how much, ma? It is N multiplied by M into V1 divided by V1 plus V2. Clear? N value 2. Because 2 hydrogens are present now here. So N value is 2. Multiplied by molarity is how much, ma? 10 power minus 3. Multiplied by initial volume is 1 liter divided by V1 plus V2. 1 plus 4. That's all, no? 4 liters is added. So therefore 2 into 10 power minus 3 divided by 5. 2 by 5. 0.4, no, approximately 0.4. Okay, ma? So 0.4 multiplied by 10 power minus 3. Okay. So this is the pH of the solution. H plus of the solution. pH how can I calculate? 3 minus log 0.4. That's all. This is how I can calculate pH of the solution. Understood, Nama? That's it. Very simple. Okay, ma? So case number 7 is pH of weak acid. Ma. Okay. So what is meant by weak acid? Weak acid means what? Weak acid means its dissociation constant will be very less. That is the meaning of this one. It means all the molecules, they cannot be divided into H plus ions. Are you able to understand? Ma? It means it's a Ka value. What is meant by Ka? Already we have studied in the previous classes. Nama. Dissociation constant will be very less. Okay, ma? So it means that all the molecules, they are not dissociated when they are put in water. Okay. Now, for example, if I take any acid, for example, let us take Ha. This is an acid. So this dissociates into H plus and A minus. Are you able to understand? Ma? So Ashish, manlokamlo ravali. Clear, ma? So this is an acid, so which dissociates into H plus and A minus. Now let us take the initial concentration of this acid is C. Okay, ma? And definitely H plus concentration will be 0 and A minus concentration also will be 0. At which time, ma? At T is equal to 0. That's all. No? Now I am not studying in terms of number of moles. I am studying in terms of concentration of acid. Okay. So initially total acid will be present in the form of Ha. So total its concentration will be C. And concentration of H plus 0 because still it has not dissociated. No? And concentration of A minus also will be how much? It is also 0 at T is equal to 0. Are you able to understand? Ma? Then at equilibrium. At equilibrium, what I can write? I can write C minus C alpha. This is how I can write. It means what is the reduction of concentration of acid? Ma? Acid concentration has reduced by C into alpha. Okay. Therefore, the increase of H plus concentration will be there, no? And it will be exactly equal to C alpha. And the concentration of A minus also will be how much? It is also equal to C alpha only. Are you able to understand? If reduction is C alpha, increase of concentration of H plus and A minus is also C alpha. No? So what is the concentration reducing here? Same concentration will be increasing also in the case of products. Are you able to understand? Ma? So this is Ca and this is C alpha and this is also C alpha. What is meant by C? C means what? C means concentration. Okay, ma? And what is meant by alpha? Alpha already we have studied. No, ma? Alpha is called X by A. Okay. So X is called degree of dissociation. Okay, all these terms I am writing here. X is called what? Degree of dissociation. Okay, ma? Or you can call it as extent of dissociation. And A is called what, ma? A is called as total number of initial moles. Total number of initial moles of what? Of the reactants. Are you able to understand? And what is alpha? Alpha is called as fraction of dissociation. Fraction of dissociation. Are you able to understand? So this is how I can write the concentrations at equilibrium. Okay, ma? Now by using this relation I can write H plus ion concentration of this weak acid. Okay, ma? Or you can call H plus concentration of this solution is equals to, it is nothing but C into alpha. Okay. H plus ion concentration is how much? It is nothing but C alpha. Okay. And this, for this one we have a formula which is called as square root of Ka multiplied by C. This is one more formula which you are supposed to remember. Are you able to understand, ma? So H plus ion concentration of solution is how much? It is equals to C into alpha. And one more formula is square root of Ka multiplied by C. Okay. What is Ka here? Dissociation constant of acid. Clear? And C is nothing but initial concentration of acid. Are you able to understand, ma? So this is the most important point which you should remember here. So I think 2 or 3 times previously questions were given directly on this relation. Okay, ma? And same concept you can write for weak base also, ma. Are you able to understand? Same type of discussion we can do for weak base also. Weak acid, weak base, same type of calculation only, no? So you better do one thing. You can write in brackets for weak base also. Okay. So if I want to calculate for weak base, then instead of H plus what I have to write? OH minus. OH minus concentration is equals to again C into alpha square root of Ka multiplied by C. Same calculation. Are you able to understand? So therefore, from this I can calculate alpha value, Nama. What is alpha value? Alpha value will be how much? This is equals to square root of Ka multiplied by C divided by C. Okay. So C, if I want to take inside this root, then I have to write Ka into C divided by C square. I can write like this. So therefore square and C get cancelled. So alpha value is how much, ma? Alpha value is equals to square root of Ka divided by C. But in which condition? But alpha should be much less than 1. For this condition, we can use this relation of alpha. Okay. Alpha value is very less than 1, much less than 1. Why it is much less than 1? Because alpha is nothing but fraction of dissociation. No? So this is a weak acid or a weak base. So dissociation will be very less. Only very few molecules only will dissociate. So therefore, X value is much smaller when compared to A value. So automatically alpha value is much less than 1. So when alpha value is much less than 1, then you can use this relation for alpha. Alpha is equals to square root of Ka divided by C. Are you able to understand? Okay. Clear, ma? So therefore, completed, ma, up to here. So these are some formulae which you are supposed to remember, ma. So until case number 6, it was very easy, no? Now from here onwards, because we are dealing with weak acids and weak bases, here we have to study some formulae. Are you able to understand? So write down. Okay. So therefore, now let us see how I can calculate pH of this particular weak acid or weak base. Okay, ma? So, what is the equation of H plus ion concentration of solution I have written, ma? It is equals to C into alpha, and it is also equals to square root of Ka multiplied by C. Are you able to understand? So if this is the H plus ion concentration of the solution, then how can I calculate a pH of this solution? pH, what is the formula for pH, ma? Negative logarithm of H plus ion concentration of solution. That's all, no? Clear, no? So this you can write like this also. This you can write 10 power of minus pH also you can write. Are you able to understand? Or if it is a base, OH minus concentration of solution, you can write 10 power of minus POH also you can write. Actually from this relation only we have derived this logarithm. You know how to apply logarithms, no? Okay. Now see, ma'am. So this is negative logarithm of, what is the H plus ion concentration of solution? Square root of Ka multiplied by C. So I will write root Ka multiplied by C. Are you able to understand? So then I can write this one as negative logarithm of, clear, ma? I can write Ka multiplied by C power 1 by 2. Can I write like this? So this power 1 by 2 I can write here also, no, ma? So minus 1 by 2 log of Ka multiplied by C. I can write like this. Are you able to understand? So then what I can do, see, ma, this is of the form of log m into n, no? Log m into n, if you separate, how can you write? Log m plus log n. So therefore I will write like that also. So pH can be calculated as minus half of log Ka plus log C. This is how I can write. Okay, ma? Now you multiply them by minus 1 by 2 individually. So therefore pH is equals to minus 1 by 2 log Ka minus 1 by 2 log C. I can write like this, no? Are you able to understand, ma? So therefore this equation again, how I can write a pH can be written as 1 by 2 multiplied by minus log Ka minus 1 by 2 log C. I can write like this also. Okay. So negative logarithm of Ka can be written as p to the power of Ka also, no, ma? Okay. Therefore how can I write? I can write a pH is equals to 1 by 2 multiplied by p to the power of Ka minus 1 by 2 log C. Okay, ma? So this is the equation to calculate pH of the solution if the solution is made up of weak acid or weak base. This is the formula. Are you able to understand, ma? So all this calculation is just for your understanding, ma? So what are the important points which you have to remember? This is the first equation which you are supposed to remember. This is the second relation which you are supposed to remember, and this is the third relation which you are supposed to remember. Understood, ma? So from these three equations only you will be getting questions. Is it clear? So H plus ion of solution or OH minus of solution of the weak acid is equals to root Ka multiplied by C. This is one formula. And the second formula is alpha can be written as square root of Ka by C if alpha value is much less than 1. Second formula. Third formula is pH of weak acid or POH of weak base. How can I calculate? Half of Pka minus half of log C. That's it. Is it clear? Make a note. Okay, ma? So case number 8 is we are discussing about the mixture of strong acid and weak acid. Both are acids only, but one is strong and the next one is weak. And the same derivation you can use for strong base and weak base also. Okay, so therefore you write down here for strong base and weak base also. Okay, so same type of derivation you can do. Okay, so see ma. So we are taking two acids, one is HA and the second one is HB. So they can be dissociated into H plus and A minus, H plus and B minus. Okay, so consider this is a weak acid and this is a strong acid. So the concentration of a weak acid is C1 and its dissociation constant is Ka. Okay, ma? Concentration of strong acid is C2 and we doesn't require the dissociation constant of strong acid. It is very, very, very large, and in this formula we doesn't require the dissociation constant of strong acid. That is not necessary. Okay, ma? So therefore, because this is an acid, I will write H plus ion concentration. Okay, ma? H plus ion concentration of solution, how can I write? I can write C2 plus square root of C2 plus 4 C1 into Ka divided by 2. This is the equation. Able to understand, ma? So by this equation, we can calculate the concentration of solution. If what are the mixtures we are taking? One is a strong acid and the second one is a weak acid. Are you able to understand, ma? And same formula you can use for OH minus concentration of solution also. Okay? For mixture of strong base and weak base also, you can use the same formula. Okay? Now what is meant by C2? C2 is the concentration of strong acid. Again C2, same. C1, concentration of weak acid. Ka, dissociation constant of weak acid divided by 2. This is the formula. Understood, Nama? Similarly, we will write case number 9 also, last case. Okay? So, case number 9. Case number 9 is mixture of, so pH of mixture of two weak acids. Okay, ma? Now we are taking two acids, ma, but both of them they are weak only, two weak acids. Similarly, same type of equation you can write for two weak bases also. Okay, so therefore you can write for two weak bases also. Are you able to understand? So therefore, let us see how we can write this one. So this is HA and this is HB. Okay, ma? So H plus and A minus. So consider this is the first acid, ma, whose concentration is C1 and dissociation constant is K1. Are you able to understand? So HB can be dissociated into H plus plus B minus. So concentration is C2, dissociation constant is K2. Okay. So then if it is an acid, H plus ion concentration of solution, how can I write? This is equals to square root of K1 C1 plus K2 C2. That's all. This is the formula. Okay. Similarly, same relation you can write for OH minus concentration of the solution also. Okay. So this is also square root of K1 C1 plus K2 into C2. Understood, Nama? So these are the different conditions which we have for the acids, bases, mixture of acids, mixture of bases, mixture of an acid as well as a base. All the conditions, all the possibilities we have studied, Nama. So these are the different possibilities, and whatever question is given, first of all you have to identify what is the nature of mixture. Then accordingly you have to solve the problem. That's it. Okay? Make a note. So in this equation we have to write C2 square. Okay, so see the question. So calculate the POH of a solution at 25 degrees Celsius. Everything is calculated 25 only, Nama. So you need not worry about this temperature here. Okay. So it contains 1 into 10 power minus 14 molar of hydronium ions. So what is meant by hydronium ions, ma? H3O plus. This is called hydronium ions, no? And hydronium ions concentration, if this is this much, then what is H plus ion concentration? Same only, no? Because every H plus will form one hydronium. That's what we have discussed previously, no? Ma? H plus cannot exist individually in water. Always they will form hydronium ions, H3O minus. So what is the concentration of hydronium ions? Same will be the concentration of H plus ions also. Are you able to understand? So right now. So the concentration of what? Concentration of H plus ions is also equal to how much? This is also equal to 1 into 10 power minus 10. This is the concentration of H plus. Okay. But what he is asking us to find out? He is asking us to find out POH, no? POH he is asking us to find out. So at the starting of this topic, one formula we have studied, no? What was that? Concentration of H plus multiplied by concentration of OH minus. This is equal to how much? So this is equals to 10 power minus 14. Do you remember? This equation already we have studied. No? H plus ion concentration and OH minus ion concentration product will be how much? 10 power minus 14. Okay. So therefore if you calculate OH minus ion concentration, then it will be how much? 10 power minus 14 divided by H plus ion concentration. Okay. So it is 10 power minus 14 divided by this value is how much? 10 power minus 10. So totally how much? 10 power minus 4. This is the concentration of OH minus ion concentration. Are you able to understand? Okay, ma? So therefore OH minus ion concentration is nothing but how much? 10 power minus 4, and this also became written as 10 power minus POH also, no? Are you able to understand? No? This is the actual formula, no? From this formula only, if you substitute in logarithms, you will get the logarithmic value. Clear? For example, if I write A is equals to 10 power B, A is equal to 10 power B, then how can you convert this one into logarithms, ma? So B is equals to log A to the base 10. This is how we convert into logarithms, no? Okay. Same concept here also. Okay. So OH minus ion concentration is 10 power of minus POH. And if you convert this one into logarithms, how I can write? I can write minus of POH is equals to log of OH minus ion concentration to the base of 10. And this minus, if it goes to the other side, then what I can write? I can write POH is equals to negative logarithm of OH minus concentration. This is how we write, no? Are you able to understand? No? So actually from this relation only, this relation was derived. Are you able to understand? By just writing this equation in terms of logarithm. Okay. So therefore, if you compare directly, you can say the answer, no? So this is 10 power minus 4, this is 10 power minus POH. So therefore, what is the POH value? 4. That is my answer. Okay, ma? So POH of this solution is how much? It is equal to 4. Okay. So based on which concept we have done this problem, ma? Based on the concept that the product of H plus ion concentration and OH minus ion concentration is equal to 10 power minus 14. Based on that, we have done this calculation. Is it clear? Right. ఏమి ఇవ్వలేదంటే 1 తీసుకోవడమే. Are you able to understand, ma? Molality that you have to calculate. pH value is given. Okay, ma? See here. So question is, equal volumes of 3 acid solutions of pH 3, 4, 5, they are mixed in a vessel. Okay, ma? So what will be the H plus concentration ion of this mixture? It means he is asking us to find out H plus ion concentration of solution. That's what he is asking us to find out, no, ma? Okay. Now first of all, we have to see what is the type of acids we are mixing. Okay. So their pH values are 3, 4 and 5, no, ma? This is a strong acid, a bit lightly strong acid, and 5 is also strong acid only. So when pH value is around 7, then you can call it as a weak acid. But this is not a weak acid. All the 3 acids are strong acids itself. Okay, ma? So therefore, if all the acids are strong acids, let us write that statement also. All the acids are strong. Okay, ma? Then how can I calculate the H plus ion concentration of a solution? Already we have a formula, no, ma? So N, or I can write, okay, N1 multiplied by capital M1 into V1 plus N2 multiplied by capital M into V2 plus N3 multiplied by capital M3 into V3 divided by V1 plus V2 plus V3. So previously we have studied for a mixture of 2 acids, no? But here how many acids are given? 3 acids are given. Now this molarity and volume, that we will study later. First of all, what is meant by capital N1, N2 and N3 values? What is a number of H plus ions which are present? Okay, ma? Number of H plus ions. So he did not give anything about the number of H plus ions, ma? So we will consider H plus ions to be 1 only. If anything is not given, we will consider this acid is made up of how many H plus ions? Only one H plus ion. So therefore we will write N1 is equals to N2 is equal to N3 is equal to how much? This is equal to 1. Are you able to understand? Now volumes. What about volumes? Equal volumes he said, no ma? So therefore I can write V1 is equals to V2 is equals to V3 is equal to V. I can write like this. Are you able to understand? Then how can I calculate their molarities? Capital M values, how can I find out? Okay ma? For example, if you take first acid, clear no ma? Then its H plus concentration of acid can also be written as 10 power minus pH, no ma? Can I write like this? Just now we have studied, no? Okay, H plus ion concentration of first acid can be written as 10 power of minus pH. Okay, and concentration is nothing but a capital M1, no? Concentration of H plus is nothing but M1. Are you able to understand? Are you able to understand, ma? So therefore 10 power of, what is the pH of first acid? 3. So 10 power minus 3. This is the M1 value. Are you able to understand how we are writing? Similarly, how can you write M2? M2 is equals to 10 power of minus 4. M3 value 10 power of minus 5. That's all, no? So now all the values we have, no? Substitute here, then you will get H plus ion concentration of the solution, and that is my required answer. Is it clear? So therefore substitute. So H plus ion concentration of solution is equals to 1 multiplied by 10 power minus 3 multiplied by V plus 1 multiplied by 10 power minus 4 multiplied by V plus 1 multiplied by 10 power minus 5 multiplied by V divided by V plus V plus V is how much, ma? 3V. That's all. If you do this calculation, you will get the required answer. Okay, and the answer is given as 3.7 into 10 power minus 4. Okay ma? 3.7 into 10 power minus 4. So this is the H plus ion concentration of this mixture of 3 strong acids. Is it clear? That's it. Make a note. ఒకవేళ చేసుంటే చూడండి మా. So hydrogen ion concentration of 10 power minus 8 molar HCl aqueous solution at 298 Kelvin. Okay, so see. So therefore what is given ma here? H plus ion concentration of solution is given, no? Aqueous solution. How much it is? Okay ma? That he is asking, ma. So this is what he is asking. H plus ion concentration of solution is how much? That is what he is asking. Understood, no? Now what is this one then? 10 power 8 molar HCl means what? Concentration of acid. 10 power 8 molar is the concentration of the acid which is given. That's all, no? So HCl has how much molar concentration? 10 power minus 8 molar concentration. So therefore that is called as H plus concentration of acid, and it is given as 10 power 8 minus 8 molar. Clear, no? So do you have any relation between these two, ma? Em relation లేదు. అక్క తమ్ముడు చెల్లి ఏమి కాదు. అది మల్టిప్లై చేసినప్పుడు. ఓకేమా? So if you multiply both H plus ion concentration and OH minus concentration of the solution, then it reaches 10 power minus 14. But one value is given for solution, and this is the H plus of the acid. Okay, what is the relation between them? That's it. Already we have studied now. Starting lo ide kada manam chadivindi. Okay, so H plus concentration of solution is how much? It is 10 power minus 7 plus H plus concentration of acid. గుర్తులేదా ఇది ఫార్ములా? 14 సార్లు చదివినాం ఇప్పటికే. ఓకేమా? సో దేర్ ఫోర్ హెచ్ ప్లస్ కాన్సన్ట్రేషన్ ఆఫ్ సొల్యూషన్ ఈస్ హౌ మచ్? 10 power minus 7 plus what is the concentration of acid given? 10 power minus 8. Okay, now I will try to convert everything in terms of 10 power minus 7 only, ma. So 10 power minus 7 plus 10 power minus 8, how can I write? I can write 1 by 10th of 10 power minus 7. I can write like this. Okay, so 10 power minus 7 if I take common, then I am left with 1 plus 1 by 10. Okay ma? So 10 power minus 7 multiplied by 1 plus 1 by 10 is 1.1. So it is approximately 1.1 into 10 power minus 7. So this is the H plus concentration of solution. Okay, now see which is the suitable answer for this one. Okay, first one it is not correct. This is 10 power minus 8. This is also not correct. This is also not correct. Only this value is very close to the answer which we got. Understood, no? Asal emanna unda cheyadaniki ida? Just you are supposed to remember this relation. Okay ma? H plus concentration of solution is nothing but 10 power minus 7 plus H plus concentration of acid. We are studying about single acid, that's it. This is not a mixture of acids, this is not a mixture of bases also. Okay. See this question. So what is the pH of resulting solution when equal volumes of 0.1 molar NaOH and 0.01 molar HCl when they are mixed with each other? Okay ma? NaOH, strong base or weak base? Strong base. HCl, strong acid. Both are strong only, no? So first, that is the first observation. So therefore we write that both are strong. Both are strong. Both are strong means strong acid and a strong base. So this is an example of mixing of a strong acid and a strong base. Then in this condition, first of all, what I have to do, we have studied 3 cases, no ma? When you are mixing an acid with a base, we have studied 3 conditions. What are the 3 conditions? First condition is H plus ion concentration, OH minus ion concentration, they may be equal. Then what you form? Salt will be formed. H plus ion concentration may be greater than OH minus ion. Then the solution is acidic solution. OH minus ion concentration may be greater than H plus. Then the solution may be basic solution. These are the 3 cases which we have studied. So first of all, we will compare H plus ion concentration of the of the acid. So what is the method of calculation? Ma? N into M1 into V1. This is the method, no? What is in here? Number of H plus which are present. How many H plus are present in HCl? Only one HCl. Only one H plus is present. So N value is 1. Concentration? Concentration is 0.01. Volume? Volume is it given? Ma? Equal volumes are given. So I will write V here. That's all, no? So therefore OH minus ion concentration formula M multiplied by M2 multiplied by V2. This is the formula, no? M value 1. Why? Because OH minus only one hydroxide atom molecule is present, no? So 1. M2 0.1 multiplied by equal volumes, no? So I will write V here. So if you compare these two, H plus is bigger or OH minus is bigger? Definitely OH minus is bigger. How many times bigger? Nearly 10 times bigger. So it means OH minus ion concentration is very large when compared to H plus ion concentration. That is the meaning of this one, no? So therefore I will write OH minus ion concentration is much greater when compared to H plus ion concentration. Is it clear, ma? 10 times bigger, no? So it means that solution is what kind of solution? Solution is basic solution. Okay. And for a base, pH value will be how much? It will be greater than 7. Much greater than 7. Why much greater than 7? Because OH minus ion concentration is much greater than H plus. So pH value will also be much greater than 7. What is the only option? That's all. That is my answer. Calculation. Is it clear, ma? So without calculation I can say answer is 12.65. That is the method of calculation. Calculation also ledante malli nenu chestantanu evanu. Are able to understand ma how we are doing? So therefore, and if you want to do the calculation, what is the method of calculation, ma? So OH minus ion concentration is equals to, so which one is having higher concentration? Base is having higher concentration, no? So M multiplied by capital M2 V2 minus N into M1 V1 divided by V1 plus V2. And if you substitute in this formula, then also you will get the answer. Okay, ma? But here no need of doing any calculation. pH should be much greater than 7. And only option greater than 7 is 12.65. That is our answer. Okay. Okay. So this is the next question. Now, which of the following is true for any diprotic acid? So what is meant by diprotic acid, ma? Okay, ma? So any acid which can give 2 H plus ions is called a diprotic acid. Are you able to understand, ma? So for example, if you take H2SO4, this is a diprotic acid, no? This can give 2 H plus ions. Okay, ma? And HCl can give only 1 H plus ion, so it is not a diprotic acid. Okay. So for example, he gave any one diprotic acid, ma, H2X. So how can I dissociate this one? This I can dissociate into H plus plus HX minus. I can dissociate like this. Clear, nama? H2X can be dissociated as H plus and HX minus. Okay. For this one, the dissociation constant is let it be Ka1. Okay. And this HX minus can again be dissociated into H plus plus X2 minus. Like this also I can dissociate this one. Okay, ma? And for this second reaction, the equilibrium dissociation constant is K8. Now this is what he is asking. What is the relation between both of them? Relation between both of them is Ka1 is always greater than Ka2 is always greater than Ka3, and it goes on like this. Okay, ma? So when it is releasing first H plus, then the dissociation constant is always greater than when it is releasing the second H plus ion. Are you able to understand? So therefore, which is my option? This becomes my option. Ka1 will be greater than Ka2. Clear? Right. So Sima. So at 25 degrees Celsius, the dissociation constant of a base BOH is 1 into 10 power minus 12. Okay, ma? So therefore, dissociation constant of base is how much? So 1 into 10 power minus 12. Okay, ma? So when you look at this data, immediately what you should understand. Dissociation constant is very less, no, ma? 10 power minus 12 one time, it is very, very less. It means it is a very weak base. That is what we have to understand. Are you able to understand, ma? So if it is a strong acid or a strong base, dissociation constant will be very large. But K value is very small. It indicates that dissociation constant is, if it is very less, then it should be a weak acid or a weak base. Clear, no? And BOH. BOH means definitely this is a base, no? So therefore, this is a weak base. Okay. Then what he is asking us to find out, concentration of hydroxide ions also he gave. It means the C value is how much? 0.01 molar. Then the aqueous solution of base would be. Then the concentration of OH minus ions he is asking. It means he is asking OH minus ion concentration of solution. This is what he is asking. Can you say? Which formula can I use? See the formula of a weak base. Huh? Root of Ka multiplied by C. This is the formula. Already we have studied, no? Okay. So pH value or POH value, how can you calculate? It is half of pKa minus half log C. This is how I can calculate. Clear, no? But he is not asking POH value. He is just asking OH minus concentration of this solution. And this is the formula. Clear, no? So just substitute in this equation. So Ka is how much, ma? So 10 power minus 12 multiplied by, what is the concentration? It is 10 power minus 2. Clear, no? So total how much, ma? It is equal to root of 10 power minus 14. So 10 power minus 7. Is there any answer? Option D. So 10 power minus 7 is our answer. Clear, no? That's all very simple.